to give you a little bit of science here. So that's basically a molecule we found. It's sitting in the pocket over there on the left. Importantly, we've tested this extensively in the laboratory against cancer cells. We know it hits the sphingosine kinase protein. We know it doesn't hit other proteins, which is a really difficult task to do. We know that it kills cancer cells, and it doesn't seem to hit normal, which is fantastic. It's exactly what we want, because if it did have other targets, it might cause side effects later on when we eventually get it into patients. So that's very important to do all that testing. So I just wanted to show you a little bit about the chemotherapeutic resistance setting. So here, I guess I'll take this with me this time. I've got some cell lines. These are ovarian cancer cell lines. And when we use low doses of the chemotherapy, doses that are so small it won't affect the cells. You see, this is the number of cells that are alive there. So 100% of those cells are alive. We treat them with a small amount of chemo, they don't die. We treat them with a small amount of R inhibitors, and they don't die. But importantly, other way around, when we put small doses of them together, we suddenly see this massive increase in the death of those ovarian cancer cells. And that's because that SK protein is sensitizing the cells to the chemotherapy, and suddenly it's able to fall over and die rather than ignoring the signal to die like it was before. And I've just wanted to throw in this last little bit of really exciting data where I was lucky enough to receive a patient sample through our clinician, Martin, and I was able to get some patient cells. Unfortunately, this woman is resistant to chemotherapy, so she is one of those people that's battling chemo-resistant ovarian cancer. And we've put that into our assays, and we're looking at whether or not we can kill it with chemotherapy. So the standard of care carboplatin here in the blue line, you see that that's the number of cells alive again. As we increase the dose, we eventually can kill them, but we have to use huge doses. But with our new inhibitor here, they die extremely quickly with low doses of our drug. And so this is where we're at, and I'm trying to push this ahead further. And it's, I think we could probably look at maybe if this is also a frontline therapy down the track, but that obviously needs a lot more work. So I just wanted to step back and put it all into context. Obviously, this is a very early stage project. I wanted to just tell you the pipeline to drug discovery and development and getting something into the clinic is a long road. I'm right at the beginning, well, not at the very beginning, but I'm at that, just leaving the early phase research here where we've got to show and validate everything we do before it then goes into some more hardcore preclinical testing to make sure everything's really right before we go into this section here and we can actually go into patients. So I'm somewhere in here on a very long road towards this. But I think what we've shown so far is that our inhibitor is looking really promising, and I hope to continue this work and get it all the way through to the other side.